Hello and welcome to today's lesson on Newton's first law. In today's lesson, we will begin by covering the full statement of this law and sketch out its meaning. Next, we will look at the first case which this law relates to, objects at rest. Finally, we will then move on to the second case, which involves objects in uniform motion. Newton's first law of motion is a key concept in physics and can be stated as follows.
An object at rest remains at rest, and an object in uniform motion remains in uniform motion at a constant speed unless acted on by an external force.
To put it simply, when an object is at rest or moving at a constant speed in a straight line, it is in a state of balance. This means all the forces acting on it cancel each other out, resulting in no net force causing any change in its motion. Let's break this down further. First, consider objects at rest. According to Newton's first law, any stationary object will remain stationary unless an external force is applied to it. For example, if you have a book lying on a table, it will not move on its own. It stays in place because the forces acting on it, such as its weight pushing down and the normal force from the table pushing up, are balanced. This is intuitive. When you are looking at a book on a table, the book doesn't suddenly start moving by itself. It stays put until someone or something applies a force to move it. This clearly illustrates the point that things don't move unless there is an external push or pull acting on them. Now let's look at objects in uniform motion. The law also states that if an object is already moving at a constant speed in a straight line, it will not change its motion unless an external force acts upon it. To illustrate this, consider an ice skater gliding on a perfectly smooth ice rink. If they push off gently, they start moving. Once in motion, they keep moving in the same direction at the same speed until something interferes, like an obstacle. This is because, on idealized frictionless surfaces, there are no external forces to change the ice skater's state of motion. In reality, though, external forces like friction and air resistance are almost always present. These forces act against the motion, causing objects like cars, bicycles, or even ice skaters to eventually slow down and stop. However, in the absence of such forces, the object would continue moving at a constant speed in a straight line indefinitely. Understanding Newton's first law helps us grasp why and how objects move the way they do. Whether an object is sitting still or moving, it's all about the balance of forces acting upon it. In today's lesson, we delved into Newton's first law of motion, which states that an object remains at rest or in uniform motion unless acted upon by an external force. We examined two key scenarios, objects at rest and objects in uniform motion. In both cases, the key takeaway is that the motion or lack of motion of an object is determined by the balance of forces acting on it. Newton's first law provides a fundamental understanding of how forces influence motion, helping us predict and explain the behavior of objects in our everyday environment. Understanding this principle lays the groundwork for further exploration of more complex physical phenomena. Watch the rest of the GCSE physics course at Sophos Education.